The James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy.
In recent years, the world has made remarkable advancements in technology, and a prime example of this is NASA's James Webb Space Telescope. This cutting-edge telescope offers a fresh perspective on the universe by harnessing the power to capture abundant light from celestial bodies such as exoplanets and stars. But recently, the James Webb Telescope has made some discoveries that prove the Big Bang Theory wrong. What's interesting is that famous theoretical physicist Michio Kaku suggests that we might be living in a simulation world. Let's explore the astounding discoveries made by the James Webb Space Telescope and how they prove the idea of a simulation world. The renowned James Webb Space Telescope was successfully launched on December 25, 2021, and by mid-July 2022, it unveiled its awe-inspiring initial images. These captivating photographs serve as a reminder that America is capable of achieving monumental feats, instilling a sense of limitless potential in the hearts of the American people, particularly our children. Since then, the JWST has continuously dominated the weekly news cycle with its ceaseless discoveries about our vast universe. Positioned as the successor to the Hubble Space Telescope, the JWST is revolutionizing scientific exploration by allowing for real-time data sharing and enabling global collaboration. By analyzing the telescope's raw data, people worldwide can partake in this scientific enthusiasm, deriving fresh insights and sharing the wonder of JWST's imagery. With the aid of its infrared telescope, the JWST grants us the ability to observe nearly every facet of our universe, including distant galaxies, with unprecedented clarity, offering us a glimpse into the cosmic past. Mere days after the telescope became operational in late June 2022, researchers unearthed thousands of new galaxies that surpassed the age and distance of any previously known galaxies. Some of these galaxies may have existed over 150 million years before the oldest galaxy identified by Hubble. Among the fascinating discoveries made possible by the JWST's infrared imaging is the revelation of the creative process within the pillars of creation in the Eagle Nebula. These magnificent cloud formations, which had eluded Hubble's vision, are now unveiled in intricate detail through the JWST's infrared imagery, revealing numerous protostars. Each of these protostar clusters, encompassing vast amounts of dust and gas and surpassing the size of our solar system multiple times over, appears as minuscule red dots amidst the nebula's smoky backdrop. Furthermore, the JWST has captured images of young stars in their early stages, before they have begun consuming hydrogen. As these stars accumulate more material, their cores become denser until they reach a critical point where the hydrogen ignites, causing the temperature to rise to approximately 2 million degrees Celsius. Interestingly, while these sections of the image may appear blue to us, they would appear red in regions containing protostars. The radiation emitted by these stars corresponds to wavelengths around 6 times longer than those visible to the human eye. This not only showcases the capabilities of Webb's infrared telescope, but also provides valuable insights into the formation of stars similar to our Sun. Beyond the pillars of creation, the JWST has also succeeded in capturing imagery of the enigmatic Phantom Galaxy. Hubble's optical view of this galaxy, known as M74, reveals its stunning spiral shape and the dispersion of stars with arms extending outward from a luminous core. However, the recent Webb image showcases structures resembling heat-emitting dust and gas fibers emanating from a vibrant center, depicted in a captivating electric blue hue. By combining the imagery from the Hubble Space Telescope and the Webb, researchers have created a remarkable composite image that accentuates both the optical and infrared perspectives of the galaxy. This striking composite image was crafted by scientists from the European Space Agency as part of the FANGES International project. This ambitious endeavor employs the Webb, Hubble, and various ground-based telescopes to capture infrared pictures of 19 nearby star-forming galaxies. By incorporating the crystal-clear imagery provided by Webb, which operates at longer wavelengths, astronomers can now identify star-forming regions within galaxies, accurately measure the masses and ages of star clusters, and gain deeper insights into the characteristics of minute interstellar dust particles. The James Webb Space Telescope is undeniably transforming our understanding of the universe, pushing the boundaries of human knowledge, and inspiring future generations of scientists and explorers. With its remarkable capabilities, this technological marvel continues to unveil cosmic wonders, revolutionizing on the cosmos and revealing the beauty and mysteries that lie beyond. When it comes to discovering exoplanets, the James Webb Space Telescope has changed our view. The majority of exoplanets are so far away that they can only be seen when their host star's light dims as the planet passes in front of it. Since the first exoplanets were found in the 1990s, there are now more than 3,000 confirmed planets orbiting far-off stars, with only about a dozen of these having been directly imaged. One of the major exoplanets identified by JT is HAP 65000. 426b scientists utilize the telescope's coronagraphs, which exclude the light from the central star, together with 2 of Webb's cameras, a number of filters, and other equipment to view it. In addition to having outstanding sensitivity, the planet has a number of characteristics that make it simpler to see. For instance, this planet is far more distant from its host star than any other planet in our solar system, at a distance that is 100 times greater than that between our Sun and the Earth. It is a massive gas giant that is also incredibly big, about 12 times the size of Jupiter. Another major exoplanet investigation by James is a planet outside of our solar system, currently orbiting a star in the constellation Virgo. Named WASP 39 bits, the exoplanet is presently 700 light-years away from Earth. It is a boiling gas giant the size of Saturn that revolves around its host star at an outrageously near distance, about 8 times closer than Mercury is to the Sun. Though the planet's thick atmosphere is dominated by thick clouds containing sulfur and silicates, including sulfur dioxide, researchers were still able to detect carbon dioxide in its atmosphere using Webb's main camera and 2 of its spectrographs. This is the first time that gas has ever been discovered in an exoplanet's atmosphere. The knowledge gained about the planet's atmosphere also allows researchers to draw conclusions about some aspects of its genesis and history. The planet is thought to have formed much farther from its star than it is now as a result of the collision of smaller planetesimals. Then there is VHS 1000, 256 bits. This object is larger than a planet, but too dim to qualify as a star, and is thus termed a brown dwarf. As a result of a modified form of fusion that occurs on objects that are extremely large but too small to fuse hydrogen, this one emits a faint reddish glow. Similar to WASP 39 bits, Webb was able to pinpoint specific elements in the peculiar atmosphere of the brown dwarf, including water, methane, carbon dioxide, and potassium. The recent discoveries made by James Webb Telescope suggest that the Big Bang theory might be wrong. The discovery of the 6 galaxies defies the model of galaxy formation, which is an important aspect of the scientific model of galaxy formation. So if the Big Bang theory is wrong, how did our universe come into existence? Are we living in a simulation world? Simulation theory is a philosophical concept that posits the idea that our reality, the universe we inhabit, is actually a computer-generated simulation. According to this theory, our entire existence, including the physical laws governing our universe and our subjective experiences, is the result of a highly advanced simulation created by a more technologically advanced civilization. The notion of living in a simulation world gained significant attention and was popularized through the work of philosopher Nick Bostrom. Bostrom's simulation argument proposes 3 possibilities. First, it is possible that no technologically advanced civilization would have the desire or resources to create simulations of conscious beings. Second, if such civilizations do exist, they might not possess the capability to create highly realistic simulations. Lastly, if both desire and capability exist, it is probable that we are living in a simulation. Proponents of simulation theory argue that the advancement of computing power and virtual reality simulations supports the plausibility of our reality being a simulation. They point to the rapid progress of technology and the potential future development of simulations indistinguishable from reality. They also highlight certain phenomena and inconsistencies in our reality that could potentially be explained by glitches or limitations in the simulation. However, simulation theory remains highly speculative and lacks empirical evidence. It exists primarily as a thought experiment that challenges our understanding of reality. Critics argue that even if the simulation argument is logically sound, it does not provide substantial evidence for its validity. That's it for today. We hope you enjoyed the video. If you did, show some love and hit the like button. And don't forget to subscribe to our channel so that you never miss out on any of the amazing videos we have in store for you.
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe, not the primordial galaxies that are bigger than the Milky Way galaxy that are only 1 billion years old. Something is wrong. We may have to revise our theory of the creation of the universe.